Hi, Professor Lee. This is Tenseng Gu, the SDN final project presentation. My final project was designing Inspector, which is a packet traffic analysis tool for ONOS. So the motivation behind Inspector, there's a few reasons. First, SDN, software-defined networking, has been a game changer for computer networks as well as cellular and wireless in general, where you now have a centralized software controller that can oversee all of the traffic on your network. With this comes a lot of potential to monitor, not only monitor but also to detect security threats, intrusions. However, even up until now, good abstractions for good packet statistics and analysis still doesn't really exist. And at the same time, traditional tools that have been used for analysis, such as Wireshark for packet analysis and NetFlow for flow analysis, tend to be resource intensive, not easy to use, and also not very scalable. And then the existing current abstractions that do run SDN, such as Netcat, while they are very good for policy making, they are very limited when it comes to monitoring and analysis. So Inspector, it is extremely simple to use and very intuitive, and it's all done through a command line interface via ONOS. ONOS framework allows any app to use its command line interface. It's very fast and responsive, and because it's part of the ecosystem, it doesn't really consume additional resources. It uses what's already available at its disposal. For example, being able to intercept packets, ONOS is already doing that, and leveraging the existing power. And this is actually potentially very powerful. It can be used to detect all kinds of attack vectors, all kinds of intrusions, which we'll see in a minute. So just a brief comparison with the other methods that were mentioned earlier, Wireshark, NetFlow, Netcat, and just a sampling of the different type of attacks that can happen. You have ARP spoofing, which is when a malicious host pretends to be the MAC address of a destination IP address, unbeknownst to the rest of the network. The existing methods cannot detect this. For example, NetFlow's case, it's too low level to detect. NetFlow is only capable of detecting IP level packets, so TCP and UDP. Wireshark, you can do this, but it's very painful. You really have to go over the data with a fine-tooth comb. It's not very easy to customize. And then kind of similar theme with the other categories of attacks, port scanning, when application is pinging all the ports, scanning throughout. The other ones can do this technically, but it's very difficult to do. So it's not impossible, but it's almost impractical. Distributed denial of service attacks, kind of same theme there as well. Yes, you can detect it, but it's a very manual, painstaking process to do so. Packet counting, they all can do it with the exception of Netcat. So while Netcat is very clear and compact in its purpose and the power of the clean algebra, but it has no mechanisms to do very basic, simple monitoring, and so you're left with frenetic to do that if you choose to do so. But then you lose all the benefits of Netcat in that case. As far as using a CPU and RAM, Wireshark and F-Flow both are notorious for this. Especially as traffic speeds increase, you start to drop packets. So like in NetFlow's case, it has to actually sample because it can't process every single packet. It just incurs too much overhead at that point. And the last limitation is that the traditional methods of Wireshark and F-Flow pretty much can't really do an entire network, because you really have to have it running on every host that's receiving the actual traffic. Whereas with Inspector, because it's an SDN controller, you just need to install it in one place and you can see everything. So Inspector in action, I'm going to go to it in a little bit, but these are some of the sample commands you can input at the command line interface to check for each of those threats. So for example, if you want to see if ARP spoofing is happening, you can just type in stats, and then with the option of the Ethernet type, you can filter on just ARP packets. And with port scanning, let's say you suspect this particular IP address, you can also just narrow down packets coming from there using the TCP protocol. For DDoS, similar idea. You can see how many sources are hitting at your destination IP. And last but not least, packet counting comes with default just stats, if you want to see that. So at this point, we will run the demo. So I'll bring up the VM here, and I'm going to fire up Mininet network. This topology is the tower topology, as mentioned in my final paper. So you have the 24 hosts, and then the 6 switches. 4 of the outward switches connected to 6 hosts each, and then also to 2 internal switches. So by itself, you'll see that, and I'll fire up the ONOS command line interface as well. So by itself, without a controller, if I do a ping all, you'll notice that nothing's getting through, right? Everything's being dropped. So I'll stop that. And now back over here at the command line, I'm going to expand it because the statistics that Inspector gives is spans the whole screen. So first step is you activate the app itself, and you see I do it all complete, and you can see right there is the Inspector app. So let's activate it. So now that's activated, we'll retry the ping all command, and this time everything is being reached, and while this is happening, Inspector is collecting a ton of statistics, incurring not much additional overhead at all because it's leveraging the interceptor that's already running. It's just an additional service that processes the packets at that stage. So now when I run stats, you'll see an entire list of data. So first column, you'll see the Ethernet type, then you'll see the protocol, and then the source MAC, source IP, port not applicable in this case because it's lower level, and then destination MAC, destination IP, destination port, and then number of packets, total bytes, and then average packet size. And then at the bottom you have the aggregate counts. And this is actually what makes it very powerful, because you can see, for example, how many different IP addresses were hit, 24, how many sources, 24 as well, because in this case it was a ping all. And you can also see elephant flows by looking at the total bytes. So now let's say we want to narrow it down to ETH type. So rather than blindly typing it in, you can press tab and it will autocomplete. And this is a dynamic autocomplete, meaning it'll only show you options of traffic that has happened. So you won't be allowed to query of a type. So for example, if I try IPv6, right, no traffic matches this criteria. If I go back and try the autocomplete, there's ARP, then you'll see ARP only shows up. Now let's say I want to narrow it down to destination IP 10.004. I autocomplete. You see all the available destination IP addresses. So I want 4. Now you see this table is only just for that. And the aggregates will adjust based on the options criteria. So very powerful. And one more just quick example to demonstrate TCP traffic. I'm going to open up 2 terminals here for 2 hosts. I'm going to enable SSH on both of them. So to enable talking to each other. Okay, now so let's say I want to contact host 11. So as I'm doing that, SSH traffic is taking place, right? So if I go back to stats, I go back to ETH type, IPv4, and if I go to protocol, notice how TCP is there. So I go ahead and do that, and sure enough, you see TCP traffic right there. Source port 22, destination port 22. If I do something simple like ls, right? Basically any command that will trigger SSP packets being sent. Let's say I want to open up Wireshark, right? Some GUI program using up a lot. If I redo the command, you'll notice how the packet count went up significantly, right? And it's still going up. So that's pretty much the demonstration of Inspector. And this is the total list of options. There's 8 options you can do, which we kind of saw in the table. It's very powerful. You can combine these any which way you want, and it'll generate the subset of the total flow table to meet your needs. Future considerations, if given more time and research, create a declarative language, similar to SQL, to acquire even more fine-tuned statistics. You can also have the ability to archive statistics into an actual database on disk. Other features also include graphing capabilities. You can either generate CSV files for external application, or you can utilize the ONUS GUI to do that. And lastly, there's potential for Inspector to be reactive, not only just passive observing, but being able to set policies based on what it sees. So that is pretty much Inspector. Thank you so much, Professor, and really enjoyed this class, and really hope SDN can continue to take off and make waves. Thank you once again.